Let's carry on with the file from the previous example, and in this lesson we're going to be talking about drilling and boring. Now again, I have to make sure that we note that we are jumping out of order a little bit, but we're doing it for specific reasons. We're going to be drilling these holes on the bottom edge of this part, and the reason we're doing this is because the stock is still left above those holes. So there are some important tool functionalities that we want to make sure we explore and understand, because sometimes you'll run into parts where it simply requires you to drill these holes before you actually clear the material. So to do this, we're going to expand the gallery. We're going to select 2D drilling to start. I do also want to note that it's important to understand the distinctions that you have when you're selecting holes. You can select arcs, you can select the internal faces of these, for example, and there are some advanced options to allow you to use tapered holes or split holes. In our case, I'm going to select the bottom edge of both of them. Make sure that I am grabbing. Reminder from previous courses, you can use the auto cursor arc center option in quadrant points. Once we have these, I'll say OK. I'll select the tool that I want to use, which is comment this as deep drilling. The next, we're going to use stock, and we're going to use it based on a stock model. In this case, we'll use first pocket. Important step because it allows Mastercam to identify where stock still is, and that way it knows where to start. Are going to be important as well. We have two main options that we're going to talk about. Peck drilling. Options have very similar inputs. You'll notice that peck is set to 0.1 for chip break. The difference is we can see here in the image is the fact that peck drill retracts the bit all the way out of the bit itself is doing these micro retracts. So the difference between them, drilling a hole or drilling a really deep hole, one that is many times the depth of the tool. Retract to help clear out those chips before it goes back in and does that peck or that plunge into the stock. And this allows for coolant or air to get into those holes and help extract those chips. So again, it's or the depth of the bit or the type of drill you're using. In our case, we're going to use the chip break option. I don't have to worry about tool axis control, but I do want to jump into linking parameters. Inside of linking parameters, not worried too much about factor top of stock. We've covered the is going to be the options that are specific to what we're dealing with now, and that's so again, another important that allows us to use this, understand exactly where the tool needs to go and where, because there's still stock there. We have this calculator option, and this calculator option specific parameters. For example, the diameter of the tool, the angle of the end. Okay, and have it add that value. And the last option I want to mention here is going to be tip comp. To again take into account the tool itself that we're using. So I'm going to say OK and that tool path. With it calculated, we can lines on the screen and see exactly where the drill bit is going in relation to those holes. We can also use backplot to see this on the screen as well and see exactly where the drill is going to go down to. So we can see here the drill bit, and more specifically the major diameter of it after the taper does extend all the way through the hole. But what if we wanted to change the distance or the position of that? We can obviously go back into the parameters, we can modify the tip compensation or the depth calculator. And in this case, I would urge you to use tip compensation as a good option, especially when you're talking about adding additional breakthrough amounts, and calculating the amount of depth that's based on the drill diameter and the taper angle on the end. But we have another option as well. If we go into the geometry itself, each of these positions can be changed at their point. We can use this pencil icon, or we can right click and select change parameters at a point, and then we can control various things. For example, the jump height. The jump height is going to be the distance or the value that it goes between holes. So if we had to jump over, let's say, a feature on a model, if these holes were down in a pocket that had already been cleared out, we could use the jump height so that the retract from each hole was minimal except for where it needed to jump over a feature. We can also change the clearance of the retract at specific holes or the depth value. Now we can use arithmetic in here. We can also right click or enter any of these values to measure or use a value. For example, if I wanted to take a look at a specific z coordinate, I could say I only wanted to drill down to here. That z value is minus 2.795. But keep in mind that any of the parameters we added in the toolpath itself, for example tip compensation, will still apply. We're simply changing the selected point. We can also use arithmetic in here, like I mentioned. For example, if we needed to go an 1/8 inch, but we needed to add a specific amount, like let's say 0.05, we can do those parameters directly inside of these dialog boxes. In this case, we don't need to use the change parameters at a point because the drill holes in both cases are exactly the same. But it is extremely helpful, especially if you have holes that are the same diameter, but potentially different heights. Either some of them need to drill through into an open pocket, and you don't want to waste all that time drilling when there's no material there. From here, let's go ahead and double click back on OP1 or OP1 view sheet. So we go back to that isometric view. Before we move on, we do want to talk about doing the counter bores in here. And again, we still have stock above here, but we want to talk a little bit about some of our options. When we expand the gallery again, we have a hole making section that contains helical bore, we have circle mill, and we also have things like thread milling. Well, in this case, we're going to be using circular mill. And it's important to note that helical bore and circular mill are two tool paths that are based on a center point or an arc center point selection. For us, we want to make sure that we select the appropriate locations, and then we're going to go ahead and say okay. And then we want to that we want to use. We only have a bull nose and we have this 3/8 ball end mill. So we don't have a tool that is actually applicable in this case. So if we want to add it, we can select the tool library. And in this case, we don't have one that's in our preloaded Mastercam 2020 mill tool library. So we can open up one of the default libraries, for example, mill inch, and then we can filter and pick a tool. So if we select filter, we're going to reset all, and then we want to select just the square or flat end mill. Then we're going to take a look at a 3/8 flat end mill. And that's the tool that we're going to use for this specific example. Now for the comment, we're going to do counter bore. And then notice we have a lot of parameters. We have stock, so we can use stock again from the stock model. So this way it knows exactly where it's starting. We can go into our cut parameters and make sure that we're not leaving any material on the walls or the floors. We also have a start angle. This is going to be the position at which it starts, in this case, in relation to our coordinate system. We have roughing and finishing, so we will want to make sure that we turn roughing on. We're using a helical entry, and the helical entry is a circular entry type where it's going to be ramping down as it does the circular pattern. And this is important for most pockets that we create, but it's especially important when we're talking about circular milling. Then we're also going to turn on our finishing options. We're going to allow for a single finish pass, and it's going to be stepping over. In this case, we're going to do just 0.05, and this 0.05 is going to be that last step, that last pass. I'm also going to turn on the keep tool down option, and I'm only going to finish at the final depth. We're not actually removing too much material. We're not too worried about the stuff above it. We want to be careful. We want to make sure that we're okay in the fact that we don't want to be using the side of the tool, the non-cutting portion of the tool. So we will have to make sure that we investigate that, but that should be fine, and we want to make sure we check it. And then we have depth cuts. Because we are removing a lot of material above this where the stock is left, we do want to make sure that we add some depth cuts. And I'm going to add a value of 0.125 as our max depth cut. Remember, we're not talking about a dynamic toolpath here, so we want to make sure that we are using an appropriate amount. Then we also have breakthrough amounts if we want to go all the way through the bottom, which in this case we don't, it's a counter bore. And then our linking parameters. The depth should automatically be based on our selection, so we don't need to make any additional options there. And notice that we have the helical entry and then we have the final cut. So the last step in this process, I'm going to go ahead and make a stock model. And the stock model in this case is going to be drilled holes. Again, we want to make sure that the stock plane matches the originally created stock. We're going to be using a stock model, and this is going to be first pocket. The operations are going to be deep drilling as well as circular milling, and I'm going to hold down the control key. And I'm not worried about stock compare in this instance, so I'm going to turn that off. And then I'm going to say OK and allow it to generate our stock model. So now if we take a look at the stock model, you can see that we have done the drilling and counter boring for those holes. It does take it down. It matches the geometry on the inside because we did add that flat or square end mill. And the holes are drilled all the way through. There's no remnant or small piece that's left on the bottom because we did drill all the way through. So everything looks pretty good there. I'm going to go back to my view sheet bookmark and make sure that I save this file before we move on to the next step.